Good evening, everyone. In the last videos, we had a very clear discussion about tree data structure. Okay, so introduction to this tree data structure we covered very clearly in our last video, like introduction to string, introduction to tree, and how you can able to represent this tree in the real time, like tree terminologies. We have seen what is mean by root. So what is the meaning of node? How to represent these edges? How to represent this path? How to represent these leaf nodes, what is the meaning of height of the tree, and even we have seen level of the tree, and even parent node. So child means what, siblings means what, so ancestor means what, degree of the node means what, degree of the tree means how you can calculate predecessor and successor. All these things, terminologies we have seen in the last video. Now I'm going to start binary tree. Binary tree. Sir, the name itself is giving clarity. Binary. Bi means what? Two. Sir, a binary tree is a type of a tree, is a type of a tree in which, so each node has at most, one second. Yeah, a binary tree is a type of a tree in which each node has at most two children, at most two children. So two children should be there, sir. Okay. So at most two means what? Either zero or one or two. Either one or zero, sorry, either zero or one or two. Okay. So which are referred to as the left child, and right child, which is called as left child and then right child. Okay. So here in binary trees, so each node will have so one data field and two pointers. Okay, two pointers which is pointing, so which is pointing to so left subtree and right subtree. Okay, which is pointing to left subtree and right subtree, like this we have. Okay. So now the degree of, already we discussed about the degree, right? The degree of each node in the binary tree. Okay, the degree of each node in the binary tree, okay, in the binary tree will be at most two, sir. At most two. Okay, we'll have at most two, like this we have. So if we want, let us take one example for this binary tree. Example one. Okay, example one for binary tree. Okay, sir, what is this first example? I'm going to take one tree in this state. Okay, directly I'm drawing, sir. So this is nothing but node A. This is nothing but node A. So which is having one left child called B, okay, and one right child called C. Like this we have, right? Again, so this b is having one more left child called D, and this one is divided into one more right child called E. Like again, it is having one more left child called F, and this one is called as right child as a G. Okay, like this we have. So this is nothing but main tree. Okay, this is nothing but main tree, that is a main root node, and this is left subtree, right subtree. So left node is having again a tree with two children, one is a left, another one is right. So every node should have at most two children. That means what? So these are the valid points for that. Suppose if you have a node, a single node, if you have that node, so can have no left child, that means null, and no right child, that means null. It is a binary tree. So where we have only one node is there, there is no left child, right child. Or so your node may have only one left child, only one child, that is nothing but something like this we can have. So it is also binary tree. Okay, don't feel that we have only one subtree, one child, so it is not a binary tree. No, no, it is also a binary tree. Binary tree means what? Zero child nodes or one child, or you can also have two childs. Like this also possibility is there. So this terminology, so zero children, one child, and then two childs. So if you have like this, then such a type of tree is called as binary tree. Binary tree means what? At most two children should be there. Okay, now if you want one more example, I want to take for you people. Example 2 for binary tree. For binary tree, what is the second example? Now I am going to take some numbers, numerical values. Let us take one here. So left subtree is nothing but a 2, right subtree is nothing but a 3. For this again, left subtree is nothing but a 4, right subtree is nothing but a 5. For this left subtree is nothing but a 6, right subtree is nothing but a 7. Like this we have. Now, so example number 3. What is the third example? Third example for binary tree. So what is the third example here for binary tree is, I will take a big tree here. Now see, 6 is nothing but something like root node I am taking. Okay, for this one left pointer is there, which is nothing but a 4. And for this one right pointer is there, which is nothing but 8. So for this again we have one left pointer called 2, and right pointer is there with 5. Again we have left pointer is there for this, that is nothing but 1, and right pointer is there, which is nothing but 3. And for this we have one left pointer is there called 7, and we have one right pointer is there, which is nothing but 9. For this right pointer is there like 10. Sir, it is also binary tree. No node is having 3 children, so it comes under binary tree only. Like this we have different examples are there. Okay, now we are going to construct these binary trees in the programming format, that we will see how you can able to convert. Okay, by taking one simple example I will represent. Okay, I think you people got a clarity about what is mean by binary tree, how diagrammatically we can able to display these binary trees. Can you please confirm, guys? Do you have any doubts up to this, friends? Please confirm, everyone. Right. So next one. Okay, good. Sir, does the ordering of data in nodes matter in binary tree? No, sir. No, sir. There is a need not to be in order. We can write in any state. It can be in any order. So, but in binary search tree, we have restrictions. Okay, but here we don't have any restriction. Happily, you can able to store. So now here I want to talk about, sir, examples. It is not possible to draw these examples on the notes. That's why examples. So I'm going to take diagram. Okay, diagram. There you can refer. I will upload that diagrams also. So properties of a binary tree. Properties of a binary tree. What are the various properties are there for binary tree? Very simple. The first property is nothing but maximum number of nodes. Maximum number of nodes on level I of a binary tree. Of a binary tree is 2 power I, sir. Okay, 2 power I. This is nothing but the formula what we have. If you take this one, okay, how many nodes are there? 2 power level is what? 0, right? 2 power 0 means what? 1. One node is there. And here level is 1. 2 power 1 means what? 2 nodes are there. This one level is nothing but 2. 2 power 2 is nothing but 4. 4 nodes are there. So maximum, I am not giving exactly, I am giving maximum number of nodes. In each and every level I is nothing but 2 power I. Second point, sir, there should be, okay, there should be exactly one path, there should be exactly one path should be there from root to any node. From root to any node, you can have only one path, sir. There should be exactly one path should be there from root node to any node. If you take a top level root node to any node, there should be only one path. Of course, it is going to have that path only. Multiple paths is not possible here. In graph, you can maintain, but in trees, there should not be. Then, so tree with tree with n nodes has exactly n minus 1 edges, so connecting these nodes. So by connecting these nodes, how many edges we should have? N minus 1 edges. Okay, suppose here if you see 1 2 3 4 5 6 7 nodes are there, right? 4 5 6 7. So how many edges should be there? 6. Sir, 1 2 3 4 5 6, right? So here how many nodes we have? 1 2 3 4 5 6 7 8 9 10. 10 nodes are there. So how many edges we are expecting? 9. So 1 2 3 4 5 6 7 8 9, right? Like this. So next property, so the height of the complete binary tree, so of n nodes is log n base 2. Of course, we will talk about this later, don't worry. Now, as of now, it is not required. The height of the tree is nothing but what? Log n base 2, sir. For example, in this case, if you take how many nodes are there? So 1 2 3 4 5 6 7, 7 nodes are there. So log 7 base 2. Okay, what is its value? Approximately, I think it is equal to 3, right? Approximately. So the height is nothing but 3. Okay, no, not 3. So 2 point something we are going to get. That means we can say 2. 2 is nothing but the height. So here how many nodes are there? 10 nodes. If you take log 10 base 2 means, if you take this as a 2 cube, approximately 8 means 2 cube means what? We are going to get 3 point something. That means 3. So 1 2 3, 3 is nothing but height of the tree, like that. Of course, in detail we will discuss in next complete I mean level, sorry, but you can say balanced trees are there we will talk about. So, okay, this is nothing but what are the various properties are there for binary trees. Next, sir, binary tree representation. Okay, binary tree representation, how we can able to represent these binary trees, I need to talk now. How you can able to represent binary trees? So there are two ways. There are two ways are there. There are two ways are there to represent. So binary trees. There are two ways are there to represent binary trees. One is nothing but sequential representation. One is nothing but sequential representation. Second one is nothing but linked list representation. Okay, we have sequential representation as well as we have linked list representation is there. So each node is sequentially arranged from top to bottom. Each node is sequentially arranged from top to bottom and from left to right. Okay, left to right. So here, let us understand. Let us understand this technique. Let us understand this method. Sir, here it is, we can understand this by numbering. Okay, by numbering each node. So the numbering will start, the numbering will start from root node and then remaining nodes, so uh, will given with increasing numbers. Okay, increasing numbers in level wise direction. Okay, so if the nodes are in same level, then so the movement of this pointer, the numbers will be will be assigned from left to right, like this we have to give. This is called as sequential representation. Sir, if you see this diagram, how we are going to represent the numbers? This particular node is available in, okay, which location? 0th location. Since it is a sequential representation, something like we need to maintain one array. We need to maintain one array. In this value is available in 0th location. Okay, so I will take this one for easy understanding purpose. So this one is available in 0th location. Okay, now sir, next, in this level, do you have any other nodes? No. So go to the next level. Level wise we have to go. Sir, this level wise, here we have two nodes are there. Let us numbers these things from left to right. So first node, second node. So in first location we have B, and in second location we have C. Okay, first location, second location. Move to the next level. So we have 3, so 4, 5, 6, because it is in same level. So we are going to give, so D, next node is E, next node is F, next node is G. Like this we have. So 3, 4, 5, 6, like this we have. Okay, I think you people got very clear clarity about this one. Okay, right. So do you have any doubt in this sequential representation? Don't worry, I will take a few more examples for you to understand. Any doubts? Clear, right? So here also we have some formulas. You can find out left child of any node n with formula 2n plus 1. You can find right node of any child by using 2n plus 2. Suppose consider n is equal to 0. In 0th location, which node is there diagrammatically? You can see root node. In the 0th location, we have A. Sushant, please wait. This is, I am talking about representation. While constructing the tree, see, any order in the sense, these numbers. So here you can see one, in what point I explained that is, in some trees, the nodes which are available in the left side should be less than this root node. Okay, like this. The elements which are available in the right subtree should be greater than this node, like this. So this is the order which we have to follow in binary search trees. But it is binary tree. The order in the sense, you can store any number, no problem in this tree. If you want, you can take 20 here. If you want, you can take one here. If you want, you can take one here. Like anyway, the node can be existed anywhere in the tree. Coming to the representation, in which position it is there, we have to give. So random positions we can't give, right? Sushant, are you getting my point? Got it? Right. So the representation where this node is available, compulsory you have to give in this format only. But the alignment of nodes while constructing the tree, so is this second node should be left child of one, means no, there is no guarantee. You can take in anywhere that we have an option. In that context, I explained. Because one student asked about that doubt. That's why I explained. So if n is equal to 0, so what is the position there? A, right? A. A is nothing but what? Root node. So left child for A, I want to calculate. Sir, what is the formula? 2n plus 1. So what is the 2n here? 2 into n value is nothing but what? 0. That means 0 plus 1. So in first location, which element is there? B. B is nothing but left child for A, sir. Now I want to take right child of A. What is the formula? 2n plus 1. Sorry, 2n plus 2. So you know when n is equal to 0, it will become 2. So right child will become second position. That is nothing but C. Sir, I want to calculate left child for which node may be considered. So I want to calculate left child for C. So where C is available in the diagram, you can, I mean, in the positions you can see, this is the C position. That means n value is equal to 2. So what is the formula here? 2n plus 1. So 2 into 2 plus 1, that means 4. 4 plus 1, that is 5. So in fifth location, which node is existed? See in the array F will become left child. Correct, right? Yes. Similarly, if you want to find out right child, then 2n plus 2. So 2 into 2 plus 2, which will become 2 into 2, 4 plus 2, which will become 6. So in sixth location, which node is there? G. G is nothing but right child. Like this, we can find. This is called as what? Sequential representation of a tree. Okay. Sir, in linked list also we can represent. In linked list representation, so each node will be having three fields. One is used to maintain left pointer. Second one is maintaining data, and the third one is pointing right pointer. Okay, like this we have. Anyway, diagrammatically I will show you how it will be. So here, if you want to represent one tree, just we are going to maintain like this. I'm representing this one. So what is the root node? 1. Left pointer is pointing to again one more node, so which is having data as a 2. And right pointer is pointing one more node with the data 3. Sir, right field is null, left field is null, because we don't have any children for this. Okay, like this we can represent. Okay, I think you people got some clarity about representation of these binary trees. How you can able to represent these binary trees? I think you people got very clear clarity. Can you please confirm any doubts up to this? Everyone please respond. Clear? Right. Now, sir, I want to go with construction of binary tree. How you can able to construct a binary tree? Sir, using sequential manner, using sequential representation. Okay, using sequential representation, I want to construct a binary tree. Very simple. Here we don't have any rule. Like if I want to insert these nodes, so in binary search tree, we have to follow certain rules. Like the root node we have to assign, and you have to insert a node to the left pointer where it should be less than the root node value. And if you want to insert a node in the right pointer, right side, right child, then it should have greater than that root node. Like that, we are going to follow some formula. But here, such type of terminology is not there. That's why, sir, we are going to depend on orders. We have some 3 orders are there. Maybe you have heard about this, but don't worry, in today's session only we will discuss about that. One is nothing but, so pre-order. Okay. Second one is nothing but post order. Okay, post order. Then third one is nothing but in order. Next one is nothing but level order. Okay, you can take any order the data. If you want to construct a binary tree, then input for that binary tree is nothing but in which order you are representing the data, in which order we are representing the data. Suppose if the data is in pre-order, then we have to follow one technique for inserting, for constructing the tree. If the data is in post order, we have to take some representation. If the data is in order, then we need to go for some representation. If it is level order, then we need to go for some representation. Okay, but I am not discussing all these order. I will construct, I want to build a tree by using pre-order data. I'm going to build. Sir, how this pre-order will be looks like? All these things I will demonstrate by using diagram. Listen carefully. Sir, here I want to build a tree. The data I'm going to give like this. So 1 followed by 2, so followed by 4, followed by -1, followed by -1, followed by 5. So followed by -1, followed by -1, and then 3, followed by -1, followed by 6, followed by -1, -1. Like this, I'm going to give, this is nothing but what? A pre-order. Okay. So this is pre-order traversal. Like this we can take. Okay. For any tree, this will become pre-order traversal. So in this pre-order, the order which we are going to follow is nothing but first we have to concentrate on root. Then you need to go for left child. Then we have to go for right child. So that means here, this is nothing but the first one root node, sir. First element what we have here is root node. One is nothing but root node. Okay. I constructed root node. Take the next node. Next node will become left pointer, left child, left node of this root node. So it is nothing but left pointer, because after root we have to visit left. So your left will become 2. Like this we are going to get. Sir, next we have 4. 4 means what? Again it is a tree. Again it is a tree. It is a subtree. Okay. So if it is again a subtree, for left again we have to apply. So this root left and right principle. So now 2 is the root. Left node will become what? 4. So your 4 will become left node. Okay. Sir, again it is a node, right? A subtree, right? For this again we have to go for left and then right. Root node is 4. What is a left pointer here? -1. -1 indicates null, sir. -1 indicates null. That is the indication why I have given minus. So its left node is null. If it is left node is null, no need to expand this. No need to expand this. So take the right node. Right node is also -1. So it is also null. Okay, sir, that's all. This task is completed. Now root node we visited. So left pointer we have assigned. Now what is a right pointer? Which is nothing but a 2. For 2 right pointer we have to take. Sir, what is the 2's right child? It will become 5. Since it is also a subtree, we have to visit root node left right principle. Root node is 5. What is a left? Left will become -1. That means null. And right node will become -1. Like this we have. So until you are getting -1, you need to keep on constructing the tree. Sir, this task is also completed. Now come to the main tree. Root is 1, left subtree is 2. Now you have pending to right subtree. So right subtree, which node we have to take here? 3. Okay. Now again it is a tree, right? So we have to follow root left right technique. Root we have created. So left. Sir, again it is a tree, right? Okay. Sir, what is the value? -1. -1 means what? Null. No need to expand. So it is finished. Go to right. Again it is a tree, right? So again it is having which rule? So we have a root node left and then right. So this 6 will become a root node for that. What about the left pointer? It is nothing but -1. That means null. And right node, it is also null. So this tree construction got completed. This tree reverse back completed. This is right only. We don't have any other points. So all these trees got constructed. I can say this is nothing but a binary tree for the given data. Sir, what is this order traversals? What is this order traversals? If you see here, first we have to visit. Okay. Sir, 1 second. Please wait. One emergency call. Please wait. Yeah, thank you. Raja, I think there was some issue with these videos. So some maybe file names they have kept differently and they uploaded in the wrong folder, I think so. So I think those videos got removed or still it is there. I will check with admin team today. Okay. Okay, okay, removed. Bitwise operators video is not there. Okay, I will check it. Okay. Notes was not uploaded. Okay. You are talking about a 5 p.m. batch, right? Correct, Raja? Yeah, yeah. I think I copy pasted only the latest one. Hmm. Yeah, all these things are available for 7 p.m. 1 second, I will write a note for 5 p.m. batch. 5 p.m. batch. Uh, Bitwise operators. Last running notes is not updated. I will do that today while uploading. I will do that modification. Okay, don't worry. Yeah, right. So like this, we can construct these binary trees, sir. Like this, we can construct binary trees. Sir, what is this order? I told pre-order. Pre-order means first we have to visit root node, then left node, then right node. DLR principle. Here D is nothing but root. Because for right and root we have common words are there. That's why I am representing root as a D. So L means left subtree. So R means right subtree. Like this we have. Okay. Now first root node we have to visit. What is a root node? 1. Next left subtree is there. Left subtree is again a tree, right? So in this, which is the root node 2? Then what is its left subtree? Again it is a root node. Is there any left child? No. Then we have to visit only 4. Left and right are not there. Then this node visit completed, this node visit completed, this node visit completed. So root completed, left completed. What is a pending? Right. Like this we have. This one is also completed. So root node completed, left subtree visited, right subtree. Right subtree is again having a root node, right? So 3. What is its left child? No. So it is visited. What is its right subtree? 6. Is there any childs? No. This is nothing but pre-order traversals of this tree. Sir, is it the same as this one? Yes, except -1. So 1 is there. Okay. So 2 is there. So 4 is there. 5 is there. Okay. 3 is there. 6 is there. Just I have not mentioned that -1 in this representation. This is the way how we can able to build a binary tree by using this array representation. I hope, I mean sequential representation. You people got clarity about this one. Any doubts, friends? Please confirm. Clear? Right. So I will take a program for this, because once if you see the program, then only you people will get clarity. Okay. So I want to construct a tree. I want to construct a tree by using this program. Sir, if -1, I want to add, then no, no, we should not add -1. We should not add -1. Now listen carefully. Sir, in main method, I have one array is there called nodes. I have one array is there called nodes. Sir, what are the elements that we have? 1, 2, 4, -1, -1, 5, -1, -1, 3, -1, -1. So 6, -1, -1. I think so. These are nothing but the elements what we have. Correct? So 1, 2, 4, -1, -1, 5. So -1, -1, 3, -1. Okay. 3 -1. Only 1 -1 is there after 3. Hmm? Then so 6 -1 -1. So how many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. right? Now I want to create a binary tree for this. Binary tree, I'm creating object is equal to new binary tree. So I need to take one class for binary tree like this. So now what I'm going to do, system dot out dot println of object dot I want to build a tree. Okay, build a tree. Okay, build a tree where I'm going to pass this array. Okay, and I want to call the data field. I want to call the data field. Of course we will talk about that later. So just I'm going to construct build tree which is going to take input as a nodes. So here I want to define a function which is nothing but a build tree which is taking array of nodes. By using this we have to construct it. Sir, what is the return type? Once if the tree is constructed, see here, this entire tree got constructed. Sir, which node we have to take it as a reference? Mainly this node is our important requirement. Root node we have to return. So return type is node. Return type is node. So I'm going to take a return type as a node. It will return which node, sir? Root node. Sir, if you ask the data of this root node, the output should be 1, right? Because for this tree, what is a root node value? 1. Now we need to check how to construct this tree. Very simple. If you want to construct this tree, you need to maintain index. That's why I am taking static index is equal to default -1, and we need a node representation also. Okay, here I am going to take a data field and I am going to represent the left node, and then I am going to maintain another pointer to represent right subtree. Whenever you are creating a node, I will pass only data field. So this dot data will become the data, and this dot left pointer is pointing to this null, and this dot right pointer is always pointing to the null. Like this we have. Okay, like this I'm going to take. Sir, next, that's all. Now we have to construct. Listen carefully. First I am going to take index plus plus. Parallelly I am taking diagram also. Sir, is this we are implementing using linked list, right? Yes. We are taking the inputs in the form of array. Okay. Compulsory you need to maintain linked list only, because in arrays representing these links is very difficult, right? How you can represent this one? We have to go for only linked list. We don't have any other option. Okay, so already this tree is represented in the form of array only. This is in the form of array only. Okay, this is nothing but representation of tree only, but in which format? Array format. Now I need to see this physically, means what? You have to construct a tree and then you have to return the value. Are you getting my point, Vishal? Right. So this is actually tree only. This is actually tree only, but how this tree is arranged? In pre-order traversal. Now, sir, listen carefully. Parallelly, I am constructing the tree. Sir, first, what is the default value of index? My default value of index will become, let us, it is I. Its value is nothing but -1. Sir, first I will increment this value by 1 unit. So your index will become 0. Okay. Now I am checking array. If the nodes of index is equal to -1 means, then can you please return null? Sir, is it equal to -1? No, sir. That means it is not null. It won't return null. What is a continuation? Sir, can you please create a node? Can you please create a node? Okay, node is equal to, so new node I am creating with nodes of that index value. I will create a new node. That means what? Sir, a new node is going to be created. Okay, that node content is nothing but what, sir? 1. Once if you create the content with 1, what will happen? What will happen? Sir, a node will be created. Next left node is null, right node is also null. Like this we have. Right, perfect. Then what is the next step? Array, sir, your node is there, right? So its left child is, again, can you please call this build tree by passing these nodes? By passing these nodes. Again, can you create right child by passing these nodes? That's all. This one, what I am going to do. Sir, now what will happen? Listen carefully. I am representing the pointers. First, my pointer is there here. Okay. So now it is calling this one. This one got executed. It is calling this one. So left pointer node dot left is equal to, again I am calling the same function by passing nodes. Now what is the value of index 0? 0 plus plus means you are going to get 1. What is the first location? 2. Sir, is it equal to -1? No. Then it will create one more node. Where that node will be created? In this link, we are going to get that. What is the node that we are going to get? Sir, 2 is nothing but this node, and its left child is nothing but null, and its right child is nothing but null. Like this we have. Sir, next. Again, it is going to again it is going to point to the left. One more time it is going to call this one. Okay, this one 2 times executed. This one more time it is going to call. Now what will happen? Left to this, left to this. Now here this value will be incremented by 1 unit. 2, is it equal to -1? No. Then it will create a new tree here. It will create a new node here. Sir, what is that node? It will become 4, sir. And left child is nothing but null, right child is nothing but null. Like this we have. Now what will happen? Again it is going to call the same node. Sir, nodes index will be +1, 3. Sir, now what is the value in third location? -1. That means return null. Yes, null will be returned. By default it is there. So now one step back. Now 4 is there, right? For that, this right subtree is going to call. Okay, now what will be the index value? Index value will become 4. In fourth location also we have -1, return null. Okay, that part got completed. Now come back. Sir, main root node we got, right? Sir, here left child. This one right child. Sir, 4 plus 1, 5. So what is this value? 5. 5 means what? In that location we have 5 is there. It is not equal to -1. So a node will be created here. A node will be created here with the content 5. With the content 5. Sir, now again it will call for left child, right? Again it will call for left child. Sir, 5 plus 1, 6th. In 6th location, which node is there? -1. So here node won't be created. Simply it will return null. And now this one got completed. Now it is going to build for right subtree. Sir, 6 plus 1, 7. In 7th location, we have -1. So it is also null. Completed. So this left part completely finished. This right part completely finished. And main root node construction is also completed. This left part completed. Now we have right child is there for this one. Now index +1. That is nothing but 8. In 8th position, which value is there? 3. That will be constructed where? In the right location, because we are going to invoke this one. So 8. So by default, left pointer is null. 8 or 3? Sorry, it is 3, right? Sorry, sir. So it is nothing but 3. Okay, left child is null, right child is null. Now 8 plus 1, 9. This is the 9th location. So which is that one? Left pointer. Is it null, right, already? So I'm not going to disturb. Then right child. Then right child. So this 9 plus 1 will become 10. In 10th location, which value is there? 6. So its right child will become 6. So what is the left pointer to this? 11. 11th value is -1, so null. So it will be incremented by 1 unit. 12th location is nothing but -1, so null. This is nothing but a binary tree. Okay, this is nothing but a binary tree for the given thing. Now this entire node, sir, first node got created. First node got created. Next again node got created. Again node got created. Left pointer is assigned with left pointer assigned with null, right pointer assigned with null. Again main right pointer, again left pointer, right pointer, all these completed. Finally, where your node will be pointing? In this only. So I'm going to return that node. Okay, I'm going to return that node. So topmost node will be returned. So what is the root data? 1. We have to get 1. If you are getting 1, then that program is correct. Let us run this code. We need to check whether it is working properly or not. So Java C, I'm going to take test.java, code compiled fine, Java space test. You can see the root node data is nothing but 1. This is the way how we can able to build a tree by using this arrays concept. That means we are representing this tree in arrays. How you can able to construct the tree is nothing but like this, sir. Okay, I hope everyone got clarity about this building a tree by using this data. Can you please confirm everyone, is the concept is clear? Line number 29 is reading the data from array. No, we have this class is there, right, Shushant? We have BT class is there, binary tree. For that, I created object because we need to invoke this build tree method, right? Okay. So for that, I created object. By using that object, I am calling build tree. So this build tree is going to return a node. It will return a node. That node data I am printing. That means which will print root node data. Got it? I will try to simplify this in the next coming sessions. But as of now, I don't want to make it complex. Clear, Sushant? Line number 30, that's what I am telling. I have array is there. I have binary tree class object is there. In the binary tree class only, I have build tree method is there. So object dot build tree I am calling. This method is taking one array values. So that array is nothing but nodes that I am passing. So this entire method is going to return node. Node is what type of class? Node class. That's why it is going to return one node. So that node will have left child, right child data. I don't want left child, right child. I want data. Then what will happen? It is going to be printed like this. Suppose consider if you have a doubt, this node is going to return, right? I told this node will be returned. Sir, it's left child I want. Then what we can able to do? So dot left you can take. And it's a data I want to check. Is it 2 or not? Now let us see. Let us execute. We are going to get 2 as output. So I want its right child data. Sir, what output we are going to get? 3. Is it correct? Is it correct? Sir, it's left child data I want. Then what we have to do? So we have to take a left. So dot left dot data. Sir, what output we are expecting here? 4 should be there. So it's left child's left child data I want, which is not there. Null we have to get. Okay, but we are going to get null pointer exception. Maybe it is raising some issue that we will resolve later. Okay, I hope you people got clarity about how I am going to return this one. Got it, Sushant? Right, sir. Sir, tomorrow we will continue this. Tomorrow I am going to take same example. I mean, with the different nodes, I will construct the tree. And in the tomorrow's class itself, we are going to see traversals. We have different traversals are there. We are going to discuss about that traversals. So I am going to implement a program for that traversals also in the tomorrow's session, sir. Right. Thank you, guys. See you tomorrow. BFS, DFS, those things we are going to discuss in graph. Here also, maybe 1 or 2 times we are going to use that, but I won't give title for that as BFS. I will take the concept. Later in the graphs, we will talk about BFS and DFS. Okay. Right, sir. Thank you. I will upload the running notes within few minutes. You can download. Okay. Thank you, guys. Good night.